So in this video, we're going to talk about how to graph sine functions and kind of where the sine function and the sine wave comes from. So the first thing we're going to do is we're going to take a look at this unit circle up here on the graph. And I know don't worry about where it's located right now. Just imagine it has a radius of 1. And as we animate this point around the graph, the red segment is going to represent the y value for any radian measurement on the unit circle. So as the point goes around the unit circle, you see the red segment increase in length and decrease in length, and it will increase positive to there, then it decreases, becomes 0, increases negatively, then decreases negatively, and then comes back to 0 again. It's just going to keep going all the way around. And if we start to plot the lengths of that red segment as it goes around, we start to plot those on a traditional coordinate plane, we're going to start to see a wave become formed where that wave is representing the y value at any radian measure. So for example, we know that the sine of 0 from the unit circle is right here is going to be 0. We know that the sine of pi over 2 sine of pi over 2 is going to be a positive 1. The sine of pi is going to become 0. Sine of 3 pi over 2 is going to be negative 1. The sine of 2 pi is going to be back to 0 again. It's just going to continuously repeat. And if we extended this graph, right, we did more than just one period, we did more than just 0 to 2 pi, you would see this graph, this wave, just continue on forever. Okay? But because the sine takes 2 pi radians before it repeats itself, we say that the sine graph has a period of 2 pi. And we should notice that every graph here has really 5 major critical points. It has a 0 here, a 0 here, and a 0 here, which in this case are on the midline. And it has a maximum there and a minimum there. So when we graph a sine function, we need to make sure that we account for these 5 points, the starting, the middle, and the end, as well as the maximum and the minimum. That's one full period. Now we can do more than that, but that's what one full period is. Okay? So a traditional sine graph has really 4 main things that will influence the way the graph looks. So if we consider the function f of x is equal to a times the sine of b times x minus c plus d, a, b, c, and d all have a different influence on the way the graph looks. Okay, so x is going to be our independent variable, f of x is our dependent variable, or x is our input and f of x is our output, however you want to think about it. But a, b, c, and d are usually numbers that will influence the way the graph works. So a is always going to be the amplitude. What the amplitude is in any wavelength, it's the distance above or below the center that the wave reaches. So if we look back at this function here, the amplitude is simply going to be 1 because from the center it goes up 1 unit or down 1 unit right there. All right, so A is going to give us the amplitude. B is going to help us find the period. Now, what the period means is how long it takes us to repeat. So normally the sine function has a graph of period of 2 pi. B is going to be 2 pi divided by the period. So the other way that we can find the period is we can say that the period is equal to 2 pi over b. And that's going to be an important piece when we go to graph these functions a little bit later. C is going to be our horizontal shift or our phase shift. And because it's subtraction, if we have a minus a value there, that moves us to the right. If we have plus some value there, that moves us to the left. And D is going to be our vertical shift. It's going to move the graph up or down without changing its size or shape, just simply moving it up or down. D is always going to be where that midline is. So if we see in this function, the midline is actually the x-axis right here because D must have been 0. So one of the ways that we can kind of look and play with this a little bit to sort of get a better idea of what these look like is using a website called desmos.com. So here I've typed in the function f of x is equal to a times the sine of b times x minus c plus d. And this is what a full sine graph looks like. And it just continues on forever. And if we focus on this area right here, we see what we just saw in the previous program with the animated point, where it starts at 0, increases to 1, comes back to 0 right around pi units. You can see that right there is a little bit more than 3, right? Pi would be 3.14. decreases down here to -1, and then comes back to 0 right there at 2 pi. You can see that's about 6.28. It's a little bit more than 6, right? That would be what 2 pi is. So I bet we can figure out that that's going to be at pi over 2, and that's going to be at an x value of 3 pi over 2. So we said that A is the amplitude. So that means that as I move A, as I take this slider and I make A bigger and bigger and bigger, we see that the midline doesn't change. The center of the graph stays the same. It does not move left or right, but the amplitude increases. The waves get longer, and the height right here increases. So that's what the amplitude is. And as the amplitude gets lower, these waves get smaller and smaller and smaller. And if I make it less than 1, they still become smaller and smaller and smaller. And if I make it 0, well, we just end up with y equals d, so that's just a straight line. And if we make it negative, it will do is it'll flip the graph upside down. So instead of starting at 0 going up, it starts at 0 going down. So let's put that back at +1 for us for now. Okay. Now we said b is what's going to influence the period. So the period is equal to 2 pi divided by b. So as I increase b, I'm increasing the denominator. As I increase the denominator, my period decreases. And as the period decreases, then the waves get more and more frequent. So as my period decreases, the wave frequency increases. You may remember that from a physics class. Right? This looks like sine waves, or sound waves rather. Okay, and as b decreases, we find out that the wavelength increases right here. Right, it becomes less and less and less frequent. For C is going to be our horizontal shift. So C is literally not going to change the size of the graph or the shape of the graph at all. It's simply going to move it to the left or move it to the right. So we said as C becomes positive, the graph moves right. Right? C becomes negative, the graph moves left, just like this. Okay. And then D is going to be our vertical shift. So this is going to move it down, move it up. Right, just like this. So this is how our graph is going to move. So let's say we had an example. We have an example here. We have f of x is equal to 3 times the sine of 1/2 times x minus pi plus 1. Well, if we want to graph this, the first thing we're going to need to do is identify our different pieces. So in this case here, our amplitude is 3. Our value of b is 1/2, but remember what we really need here is the period. So the period is equal to 2 pi over b. So in our case here, we're going to do 2 pi divided by 1/2, and that's going to equal 4 pi. So this here, that's going to be our period. That means that when we go to create our scale of our x-axis, the scale is going to equal the period over 4. So since my period is 4 pi, I want my scale of my x-axis here to be 1 pi. So I'm going to make my first tick mark there. I'm going to call that pi. This is going to be 2 pi. I'm just going to keep counting by pi. This is going to be 3 pi. This is going to be 4 pi. Right? This could be here 5 pi. And if we went the other direction, this would be negative pi. This here would be negative 2 pi. This would be negative 3 pi. And so on. Okay, so that's just how we figure out what our scale is. We do the period divided by 4. Well, the rest of our graph here, we have our phase shift. We have pi units, right? So I'm going to write here that c is pi, and because it's being subtracted, that means we're moving to the right. And the last piece we have right here, the +1, that's our vertical shift. So our midline here is going to be 1. So when it comes time to graph it, the first thing I'm going to put on the graph after I create my scale is I'm going to draw my midline. So my midline is right here at +1, this red dotted line. And I know that I'm going to have critical points at each of these tick marks here. That's why I did the period divided by 4. So normally a sine graph, just like we talked about in this one, starts at 0, 0 and starts up. Okay. Well, in this case here, instead of starting at 0, 0, remember we were shifted up 1 unit and to the right pi units. So instead of starting at 0, 0, we're going to start right there at pi, comma 1. Ooh, what happened there? So here's our first point. And then we're going to start going up. We have an amplitude of 3. So that means between pi And my next critical point at 2 pi, we have to go up 3 units. And then to our next critical point, which would be halfway, half the period rather, we're going to come back to the midline. And then we have to go down 3 units to our next critical point, and then back up 3 units to our midline. So the sine wave here ends up looking something like that. And that would be 1 period of this function right here. But again, we know that the function is continuous. It goes on forever. We don't have just 1 period, even though we may graph only 1 period. If we wanted to continue it, we have a critical point right there at 0 pi. It comes back to our midline right here. It would increase right there to a maximum, and then come back down to the midline right there. So if we really wanted to draw another period full of it, it would go just like that. So this is now 2 full periods of this graph, where this right here, this section, is a distance of 4 pi along the x-axis, so that's going to be 1 period. And then this part here, which again, it goes from pi to 5 pi, it's a distance of 4 pi, so again, that's another full period. And this pattern is just going to continuously repeat again and again and again. All right? If you wanted the graph to be taller, you'd have to change the amplitude. If you wanted these waves to be closer together and higher in frequency, you'd have to change the period. If you wanted to move the graph left or right, you'd have to change the phase shift. If you wanted to move the graph, keep the same size, or just move it up or down, you'd have to change the vertical shift. So I hope this helps with sine graphs. If you just remember this detail right here, you should be all set. Good luck.